Hello, algebra students. Mr. Lawrence here, and we are going to run through 3 really quick problems. Graphing quadratics. Remember, the first thing I want to do is find my discriminant. So I'm going to say A, B, C, easy as 3, negative 5, 12. And I'm going to use B squared minus 4AC. And so I'll plug in using parentheses. Some of you are getting lazy, not using the parentheses there, and it's causing a sign error. Okay. I can tell right away that I'm going to get a negative discriminant. I'm going to get a positive 25, and I'm going to get a negative 144. That's a negative number. Let me see here. 45 would be 120, so it would be 119, I believe. So my discriminant is negative. It would be foolish now to go and find the zeros. There are no zeros. The vertex is going to be above the x-axis, and it's going to open upward. How do I know? A is positive. All right, so now I'm going to go to find my vertex. And we use x equals the negative of b over 2a. Okay, so I'm going to take the negative of b, which is 5, and 2a is going to be 6. So my vertex is at 5, 6. Now I can make my little table here. I'm going to put 5, 6 in for x. Okay, and let me go to my graphing calculator. What is the original equation? 3x squared minus 5x. All right, so let me clear this out, go there. All right, so let me see both. So I'm going to go 3 times the quantity of 5 sixths. Hopefully you're not sitting there searching for the ABC button like so many of you have asked me recently. Minus 5 times the quantity of 5 sixths, and then I'm going to add 12. This will be the y-coordinate of my vertex. All right, looks like it's going to be 9 something. I don't know what that is as a fraction. I'm going to subtract off the whole number, and then I'm going to go math, frac, and it looks like it's 11 twelfths. So my y-coordinate is going to be 9, then the whole number I subtract off, and 11 twelfths. All right. Now, to get my other points, I guess I should graph that one. Let me put that axis of symmetry in. And, you know, Kayla Stauffer said, do we really need to put the axis of symmetry in? No, but you need to know where it is. Okay. So that looks like it's about 5 sixths. And I'm going to plot 5 sixths, 9. Okay, and it looks like I'm going to go off the graph because I know it's opening upward, so maybe I'm going to count by 2s, or maybe 3s or something like that. So let's count by 2s. That'll take me up to 20. So 2, 4, 6, 8, 10. So 9 is going to be here. It's going to be maybe getting really close to 10, something like that. Okay, and I'm going to label it. I'm going to label it 5 sixths, and then 9 and 11 twelfths. If I want, I can show I'm counting by 1s here, and here I'm counting by 2s. All right, so now to do my other 2 points, I'd like to put 0 in whenever possible. And, all right, so I'm going to plug 0 in, and I will get 12 out. So 0, 12 is on my graph, and I'm counting by 2s, so 4, 6, 8, 10, 12. And so I'm going to plot the point 0, 12. Now, because of symmetry, I'm going to figure out how far apart these 2 points are. They're 5 sixths. Well, 5 sixths and 5 sixths would be 10 sixths, right? Well, I'm going to simplify that down to 5 thirds, which is 1 and 2 thirds. So for this number, I'm going to put 1 and 2 thirds. Oops, not 1 1/2, silly Mr. Lawrence. 1 and 2 thirds. So 1 and 2 thirds is going to be somewhere along here, and the y-coordinate is simple because I'm using symmetry. I get 12. So 1 and 2 thirds, 12 is going to be right about there. And you can laugh at me all you want, but I should be able to draw this parabola decent because the vertex and my 2 points are relatively close to each other. I don't even need to do my copy thing. Got a little bumpy there, but there you go. All right, let's try another one. Again, the first thing I do, go looking for the discriminant. So I need to know A, B, C. Easy as negative 4, 3, negative 5. And then I go b squared minus 4ac. And so I put 3 minus 4 times negative 4 times negative 5. I'm going to get 9. Oh, I know I'm going to get like a negative 80 here, I think. Yeah, negative 80. It's going to be negative 71. There are no solutions. My discriminant is negative. I'm not going to go searching for the x-intercepts. There aren't any. So I'll go to my vertex. X equals the negative of b over 2a, which is going to be 3/8. I want to go to my table. I know the x-coordinate of my vertex is 3/8. I'll figure out the y-coordinate of my vertex. So let me get my graphing calculator back up here. Hold on one second. There we go. And so I'm going to go negative 4, start a quantity, 3 divided by 8, and I'm going to square it, plus 3 times 3/8. And I'm going to subtract 5. And there we go. Now again, I don't know what that number is. I'm not going to subtract off the whole number because it's a negative. I'm going to add 4. And then I'm going to hit math frac. And there we go, 7/16. So it looks like it's going to be negative 4 and 7/16. So it'll be negative 4 and 7/16. So let me minimize that. And so 3/8 is where my line of symmetry is. So 3/8 is going to be just shy of a half, and that's kind of big and bulky. It's hard to know I'm at 3/8. So I think I'm going to make him a little bit thinner on this particular problem. And so 3/8, let me, oops, I lost it. Where is, okay. So I'll say half, 3/8 will be about there. Okay, pretty close, not exact. So I'm going to go 3/8, so negative 4 and 7/16. 8/16 would be a half, so 7/16 is close to it. 1, 2, 3, 4, half, just a little bit shy. I know it's going to open downward. How do I know? Because a is negative. So I'm going to label it 3/8 and negative 4 and 7/16. All right, so now I'm going to plug 0 in, and I'm going to get negative 5 out. And this are 3/8 from each other. The next one will be another 3/8. Well, 3/8 and 3/8 is 6/8, or better yet, 3/4. Hey, did you notice that the 3/8 turned into 3/4? And on this one, it was 10/6 or 5/3, right? 5/3, 5/6. 5/3 is twice as big as 5/6. Anyway, I can explain more about that in class if you don't know what I'm talking about. Because of symmetry, I know the y-coordinate is negative 5. So 0, negative 5 would be right here. 3/4 of the way, negative 5 is right there. Label 0, negative 5, and 3/4, negative 5. And so there we go. Something like that. All right, pretty easy. Let's do one more here. And this time, I'm going to go find a discriminant. I know what it's going to be ahead of time, but that's okay. Some of you are thinking, hey, I want to factor it. Yeah, it's actually factorable. Go ahead if you see it, but I'll do it the discriminant way. A, B, C, easy as 9, negative 12, 4. And so then I'll do negative 12 squared minus 4 times 4 times 9. So that would be 144 minus 36 doubled 72, double that, 144. I got 0 when it's factorable. That doesn't always mean you're going to get 0. That's fine. I was going to say something, but it wasn't going to be correct, so I apologize. All right, so I know I'm going to go look for my vertex, right? I'm going to do x equals the negative of b over 2a. All right, well, the negative of b is 12. 2a is 18, and I believe that's 2/3. Okay, now I don't need to find the y-coordinate. I know it. How do I know it? Well, because there's only one solution, the parabola is sitting on the x-axis. It's sitting where x is 2/3. Let me put my axis of symmetry in. Okay. And again, on this one, I'm going to make it thinner. So let me make it thin. Properties. All right, there we go. 2/3. And since my parabola is sitting on the x-axis, it's opening upward, by the way, my solution is right there. Well, what's the y-coordinate there? It's 0. 2/3 0 is on my parabola. Now I can plug 0 in to my for x, and I will get 4 out, right? 0, 4, 1, 2, 3, 4. Okay, and then I have to go 2/3 of the way there, which will be 4/3 or 1 1/3. Okay, so 1 1/3 will be about here, and it's going to be up at 4 again. So I can label this. This will be 2/3 0. This will be 1 1/3 4, and then 0 4. All right, so I'm ready to graph. Like that. And then like that. And there you go. All right, that is it. Hopefully that gets a little more practice for you. You're getting a little time in class on Wednesday to finish these papers, and then we're going to be going into something new on Thursday. All right, Mr. Lawrence signing off. Have a good night, everybody.